All right, everybody, buckle up, because today we're talking about something pretty wild. We're diving into the world of fighting climate change with rocks.
It's a fascinating concept. Definitely a new one for a lot of people, I bet.
Absolutely. So, to set the stage, we're all familiar with the climate challenge, right? Too much carbon dioxide in the atmosphere. We need to reduce emissions, of course. But what about the CO2 that's already up there? That's where the rocks come in.
I'm intrigued. Tell me more.
Have you ever stopped and looked at like a really old stone building, all weathered and worn?
Yeah, totally. You see it everywhere.
Turns out that's natural weathering in action. It's happening all around us all the time.
Right. Rainwater, even though we think of it as pure, is actually slightly acidic, and over time, it reacts with certain minerals in the rock, slowly breaking them down. The really important part is that this natural process also captures and stores carbon dioxide from the atmosphere.
So the rocks are kind of like these natural carbon sponges. They just soak it up.
Exactly. And where that carbon ends up is even more mind-blowing. They essentially become part of what's called a carbon sink, basically, a natural system that stores carbon away long-term.
Like the ocean floor.
Exactly. The ocean floor is a huge carbon sink.
Okay, that makes sense. So we've got these rocks naturally sucking up carbon. That's good, right? That's helping fight climate change.
It is, definitely. But there's a catch. Natural weathering is, well, it's natural. It takes a really, really long time. We're talking thousands, even millions of years for these rocks to break down and lock away that carbon. And in the face of rapid climate change, we need something a bit faster. And that's where enhanced weathering comes in.
Enhanced weathering. So we're giving these rocks a little boost.
You got it. By crushing rocks, specifically ones rich in calcium and magnesium, like limestone, we can dramatically increase their surface area. More surface areas means more contact with rainwater and a much, much faster weathering process.
So instead of waiting millennia for a rock to weather, we're talking decades.
Exactly. We're essentially speeding up nature's own carbon capture mechanism.
Okay, so we're crushing rocks and what? Scattering them around. Where does all this crushed rock even go?
Well, that's where things get really interesting. There's this company, Silicate Carbon, and they're doing some really cool work with this whole enhanced weathering thing.
Okay, less dust cloud, more calculated strategy. I'm listening. What's their secret?
It's all about contact. The more contact you can get between that crushed rock and, air, CO2, the better. So they're working with farmers, helping them apply this rock dust to their fields.
Wait, really? Like spreading it on fields alongside crops?
Exactly. And get this, turns out spreading this rock dust isn't just good for the climate. It can actually make the soil healthier, too.
Hold on, seriously. Rocks are good for the soil. How does that work?
Think about it. Healthier soil, healthier crops, which is great for farmers and great for everyone who, eats. Cool, right?
But how do we know for sure this is all working? Like, I get it. It makes sense on paper, but are we just trusting these rocks are doing what they're supposed to?
I'm glad you asked that, because that's a really important point. And it gets to why Silicate Carbon, the company we were talking about, is doing such important work. They're not just tossing this rock dust around and hoping for the best. They're really serious about monitoring the whole process.
So like scientists in the fields taking samples, that sort of thing.
Exactly. They're taking soil samples, water samples,
Right.
even analyzing the air above the fields. They're tracking everything.
No guesswork then, just hard data. I like it.
So they can say for sure how much carbon is being removed and all that.
Exactly. By carefully measuring everything that's happening in the soil and the water, they can see how much carbon dioxide is being removed from the atmosphere and how it's being stored. And the storage part is important because it's long-term, like really long-term.
Okay, so we're not talking about a temporary fix, right? This carbon is being locked away for good.
Precisely. Remember those carbon sinks we talked about earlier? Well, when the rock dust does its thing, it creates these bicarbonate ions. And those ions, they don't just hang out in the soil forever. Rainwater carries them into the ocean. One-way trip.
To the ocean. Okay, what happens to them there?
This is the really wild part. Once they're in the ocean, those bicarbonate ions get ready for it. They help form limestone, the same limestone rocks we crush up to get this whole process started. So the carbon we're pulling out of the air could end up as new rock formations on the ocean floor. Talk about long-term storage. And it might even help feed the planet along the way.
That's what's so exciting about this. We could be looking at a future where sustainable farming and fighting climate change go hand in hand.
Okay, I like where you're going with this.
We could be boosting crop yields, putting more food on the table for everyone, and doing it all while we're locking away that excess carbon dioxide.
Just like what? Hitting two birds with one stone.
Exactly.
Yeah.
And a very eco-friendly stone at that.
Okay, that's a future I can get behind, for sure. But realistically, how big of an impact are we talking about here? Is this a small-scale solution, or could enhanced weathering really put a dent in this climate change problem?
That's the big question, right? I mean,
Yeah.
it's still early days. We need more research for sure, more large-scale trials to see how this plays out in different environments, different soils, different climates.
So more work to be done.
Definitely.
Yeah.
But that's not a reason to just sit back and wait.
Yeah.
If anything, it's a call to action. The more we know about enhanced weathering, the better equipped we'll be to make smart decisions about, our planet's future.
So what you're saying is stay curious, stay informed.
Exactly. And support the innovators, the ones out there pushing the boundaries, because they might just be the ones who save the planet.
I like the sound of that. So next time you're walking down the street and you see an old weathered building or even just a rock on the ground, take a moment. Remember, that rock could be a key player in the fight against climate change.